The early morning of the 17th of November, 2025, began with an unease that was difficult to pinpoint. There were no storms over the observatory, no seismic activity, nor any unusual atmospheric disturbances. Nevertheless, as I reviewed the usual records, I felt an inner sensation, a quiet pressure, which often precedes significant discoveries. Hours later, this intuition materialized into a concrete fact. An object of uncertain nature, provisionally registered as #G427, had entered the inner solar system, positioned exactly in a region where we had anticipated nothing of consequence. I lingered for several minutes before the first captured image. At first glance, the object displayed a faint, barely perceptible coma, like a luminous veil without a defined structure. However, what caught my attention was not this weak halo, but what was absent. There was no trace of a tail. Neither sublimation nor the characteristic scattering caused by solar radiation was observed. It was as if the object deliberately defied the thermal laws governing small bodies as they approached the warm regions of the solar system. I checked the data repeatedly, almost in disbelief, until I confirmed that no instrumental errors were present. The tail simply did not exist. I requested a cross-verification with the northern station of the country. The Chilean astronomers who had first detected the object confirmed the anomaly. G427 exhibited an unstable fluctuating glow but never adopted the typical configuration of a comet. Minutes later, reports from two independent observatories corroborated the same behavior. Each verification intensified the unease. While examining the preliminary orbit, a second anomaly became evident. The object's motion did not follow a purely gravitational trajectory. At certain moments, particularly during its brightness variations, slight deviations in its course were detected, non-gravitational accelerations, subtle but undeniable. This observation plunged the team into immediate silence. No one dared to formulate premature hypotheses, but all understood the significance of the discovery. Any such deviation requires a specific physical cause, and none of the known causes, gas emissions, fragmentation, photonic turbulences, or thermal resonances, seemed applicable to a body without a tail, without sublimation, and without signs of deterioration. As we delved deeper into the data, a third element, impossible to ignore, emerged. The object was not alone. Its position coincided with a striking geometric alignment. G427, the interstellar visitor 3I Atlas, the wandering object Su 2025 VE1 Borisov, and the comet Su 2025 Ka1 Atlas formed an almost perfect line toward Earth. It was not an exact alignment, but precise enough to challenge any statistical probability. According to initial calculations, this configuration would be completed in approximately 72 hours. My mind resisted accepting the improbable, but the instruments did not lie. I paused my notes to contemplate the real sky beyond the screens. Although my eyes could not discern G427, I felt the disquiet of knowing that, within the constellations of Virgo and Leo, an unusual celestial structure was forming, an invisible corridor connecting bodies that were, in themselves, extraordinary. 3I Atlas, with its anomalous resistance to solar radiation, Borisov, with its wandering behavior and lack of emissions, and now this new object, appearing suddenly in a place where nothing similar should have been. The team discussed in hushed tones, avoiding categorical statements. The coincidence was too precise. Every instrument confirmed the same. The three objects did not respond to solar radiation as expected. None showed detachments, signs of thermal erosion, or developed the typical tails of volatile bodies. The hypothesis beginning to take shape, though no one voiced it openly, suggested that their composition must be extraordinarily resilient, possibly rocky metallic, or perhaps belonging to a category yet to be described in astronomy. During the conversation, an electromagnetic alert interrupted our analysis. The solar storms forecasted for that week, classified between Gu3 and Gu4, were rapidly intensifying. I observed the graph of solar activity, which rose like a chaotic wave. The temporal coincidence was unsettling. We did not know whether these storms could influence the alignment of the objects or whether the objects were reacting unusually to these disturbances. In any case, the moment was critical. We activated the field measurement protocols to assess possible interactions between solar radiation and the trajectory anomalies of G427. The results, obtained within minutes, heightened the tension. During peaks of solar activity, the object increased its brightness fluctuations, as if responding in some way to the electromagnetic environment. It was neither a linear nor predictable reaction, but not random noise either. A modulation of brightness was observed, seemingly linked to solar impulses, as if both phenomena shared a sensitivity that was difficult to define. I took notes with a steady hand, though my breathing faltered. Each new measurement reinforced the notion that we were dealing with an unknown category of interstellar bodies. These were not mere wandering rocks or primitive comets. They seemed to obey more complex dynamics, possibly tied to internal properties not yet understood. Yet, I repeated the fundamental rule: do not speculate beyond the data. And the data were clear. This alignment should not have been occurring, but it was. GU 427 had positioned itself between Earth and 3I Atlas at a crucial point, as if its appearance responded to a cosmic mechanism we could not decipher. The instruments continued to collect information, and I knew the next hours would be decisive. I sensed we had entered a realm where science becomes urgent observation, where the universe, for a moment, reveals its hidden layers. That night, in the silence of the observatory, I realized we were facing a phenomenon that could redefine decades of astronomical knowledge. We were only beginning. When the second observation phase began, several hours had passed since the initial detection of GU 427, but the scientific tension did not wane. On the contrary, it grew with each new batch of data arriving on the screens. The previous night had been revelatory, but now, with more observers focused on the object's trajectory and the systems calibrated to their maximum, I understood that the true challenge was just starting. The question echoing in my mind and those of my colleagues was whether what we were observing was a transient anomaly or a profound pattern capable of transforming our understanding of interstellar bodies. The first thing I checked was the object's photometric behavior. I activated the brightness analyzers and examined the light curve from the past hours. The inconsistency persisted, showing rises and falls that did not correspond to thermal processes, erratic rotations, or sporadic material ejections. Each variation seemed to follow a specific interval, though not enough to be considered cyclic. It was like an interrupted breath, an incomplete rhythm suggesting an unknown internal dynamic. I paused on this irregularity, careful not to fall into premature interpretations. I knew it could stem from unusual surface properties or a composition that, for now, eluded our understanding. I then requested the activation of the scattering sensors. These instruments allow analysis of how light interacts with potential particle halos or gaseous structures. However, GU 427 once again defied established parameters. Its coma, though faint, showed no fan-shaped scattering, streaks, or radial detachments that would explain the absence of a tail. It was a minimal, almost symbolic envelope, a directionless mist. This lack of orientation was, in itself, an anomaly. Any comet venturing into warm regions develops clear geometries driven by solar radiation. But this object remained impervious to ablation. At times, I had the impression it was covered by a layer that modulated its interaction with the environment, allowing it to resist thermal effects without the usual signs. As the data accumulated, another irregularity became more apparent: the non-gravitational acceleration. The previous night, we had detected faint perturbations, just enough to rule out instrumental noise. Now, with the instruments in high-precision mode, we recorded a clearer shift. It was a subtle, almost elegant deviation, occurring during moments of maximum brightness oscillation. It was neither a sudden impulse nor an erratic change, but a calculable, coherent deviation, as if the object were responding to an internal force of variable but systematic magnitude. I checked the gravitational models of the region. There were no massive bodies nearby to justify this deviation. No magnetic interactions with inner planets or dust structures were detected either. However, one element could have an influence, though not in a conventional way: the solar storm. That day, solar activity warnings had intensified. Particle ejection levels reached dangerous categories, between GU 3 and close to GU 4. Theoretically, the intensity of the solar wind could affect small bodies, typically amplifying their tails or increasing ablation. In this case, the effect was the opposite. The object remained intact and, at certain moments, seemed to react to solar peaks with trajectory variations. We activated a direct correlation between the solar activity graphs and the object's motion records. Then an even more perplexing behavior emerged. In the minutes following each increase in solar wind, the brightness of #G427 showed a momentary flattening, followed by a surge coinciding with micro-variations in its trajectory. It was not a clear relationship, but a sufficient correlation to indicate a more complex interaction than usual. For a moment, I wondered if we were dealing with a body possessing exceptional electromagnetic properties, perhaps a structure rich in metals or non-volatile minerals capable of absorbing or reflecting radiation non-linearly. The inevitable question began to form in my mind, though I kept it out of the official record. What if G427 was not an isolated body but part of a larger phenomenon? This idea gained strength as I observed the near-perfect alignment forming with 3I Atlas, the wandering object Borisov, and the Comet Atlas. I could not ignore that these objects shared a disturbing pattern: unusual resilience, absence of tails, structural stability akin to a metallic body, and now, an arrangement in an improbably precise geometry. Reflecting on this coincidence, the orbital data updated the alignment projection. If the calculations held, in approximately 72 hours, the line formed by these four bodies would intersect an almost perfect vector between Earth and the constellations of Virgo and Leo. I studied the graph closely. The trajectories converged as if drawn with an astronomical ruler, defying the typical dispersion of independent bodies. Each point was a statistical coincidence that accumulated, becoming more improbable with each refinement. Over the hours, we activated secondary and tertiary telescopes to obtain simultaneous measurements. With one of them, we managed to capture a more detailed image of the halo of G427. Though the resolution was limited, I noticed something new: a luminous texture around the object, as if its surface or coma were modulated by internal layers interacting orderly with sunlight. It was not a physical texture but a photometric pattern, a reorganization of light emerging as subtle, almost geometric edges. This reminded me of 3I Atlas, whose light had also shown unusual edges at specific phases. The visual similarity between the two objects caused an uneasy silence in the room. No one wanted to state it, but we all thought the same. The bodies were not only aligning in space but also exhibiting compatible optical behaviors. It was as if they belonged to a family of objects with properties still unknown, a new category among interstellar bodies. I began documenting each anomaly with precision, aware that we were collecting data that future scientific teams would scrutinize rigorously. Internally, I struggled to remain cautious. I knew that any excessive interpretation could jeopardize our credibility. Yet, it was impossible to ignore that we were facing an extraordinary phenomenon, requiring not only continuous measurements but also a profound revision of the dynamic models underpinning our understanding of near space. When the clocks marked the end of the session, I remained alone for a few minutes before the main screen, watching the light of G427 fade among digital particles. I understood that what was happening would not be remembered as a routine detection, but as the beginning of an exceptional event. The geometry, thermal resilience, alignment, non-gravitational acceleration, and interaction with solar storms were drawing a new map, a territory where science was only beginning to take its first steps. I knew, with an almost painful certainty, that the third observation phase would be decisive. In this final stage, we might discover whether this object was a solitary traveler or the visible piece of a phenomenon we were only starting to comprehend. The first hours of the third phase began with a silence that seemed out of place in an active laboratory. It was a dense, almost palpable silence, as if the entire observatory were holding its breath. 2 days had passed since the detection of G427, and we were now at a critical moment. The alignment with 3I Atlas, Borisov, and Atlas was less than 3 days away, and each new measurement indicated that the configuration was more precise than orbital models deemed reasonable. I knew this final session would be crucial, not for confirming a specific discovery, but for opening a field of questions whose scope we had not yet dared to gauge. We powered on the systems with utmost care, calibrating the spectrographs to the limit of their sensitivity. Solar activity remained at high levels, reaching peaks close to the G4 category, making it even more improbable that objects like G427, 3I Atlas, and Borisov could maintain their structural integrity without visible erosion. Yet, there they were, defying radiation as if their surface were immune to any form of ablation. In a way, They seemed to operate under a physical regime that effortlessly resisted conditions that would have fragmented any volatile comet. The first light signal from the object arrived minutes later as we calibrated the scattering channel. What I saw on the screen differed from previous days. The unstable glow was still present, but the curve revealed something new, a series of the finest steps, microlight switching on and off in brief sequences during the peaks of the solar wind. It was as if the object were responding to the radiation with an internal pattern of reorganization. It was neither a reflection, saturation, nor electronic noise. It was a modulation appearing only when the storm reached maximum intensity. I requested an expansion of the dynamic spectrum. While the technicians adjusted the parameters, I observed the trajectory in real time. Then one of the most perplexing phenomena of the entire campaign occurred. GU-427 executed a sustained non-gravitational acceleration, longer than the previous ones. It was not a brief impulse but a fluid, gentle, almost mathematical shift. The motion vector changed with such elegance that for a moment, I felt as if I were observing a deliberately drawn curve. I forced myself to check every detail to avoid hasty conclusions. I verified the sensor's integrity, reviewed the internal clocks, and compared the signal with two distant stations. Everything aligned. To my astonishment, during the acceleration, the faint halo surrounding the object contracted, adopting a more defined geometry. It was almost imperceptible, but enough for the photometric pattern to reveal a novel internal edge. It was not a physical outline but a luminous reorganization, a momentary order emerging in sync with the trajectory change. At that moment, I checked the position of 3I Atlas and the other two bodies. All, without exception, showed similar microvariations in brightness, as if they shared a common sensitivity to the increased solar activity. This similarity sent a quiet shiver through the room. The possibility that four independent objects from different origins could exhibit such compatible reactions defied any explanation based on random processes. I requested the superposition of the spectral curves of the four bodies. As the graph was generated, I felt a strange anticipation, as if a hidden pattern were about to reveal itself. And it did. During the peaks of the solar wind, the scattering curves showed a simultaneous narrowing, a convergent reduction never seen in known natural bodies. It was an optical synchrony, a collective response suggesting that all shared a surface or internal structure capable of reacting coordinately to intense energetic stimuli. Quickly, I asked to isolate the frequencies where the effect was most evident. In doing so, a disturbing observation emerged. During intervals of the highest solar intensity, GU-427, 3I Atlas, and Borisov exhibited photometric pulses repeating with nearly identical cadence. These were brief, discrete pulses, barely perceptible, but their temporal coincidence was too precise to be considered random. We had never recorded such a collective response in isolated bodies within the solar system. While analyzing this synchrony, the orbital projection updated, showing an even more precise alignment. The line between the four objects and Earth was narrowing to an almost perfect range. It was a geometry that, according to statistical models, should only occur on timescales vastly exceeding human lifespans. Yet, it was happening now, before us, under extreme solar conditions. This coincidence prompted me to activate a tool reserved for high-interest anomalies, coherence edge analysis. This process reveals internal reorganizations in light, enabling the identification of hidden structures beneath the optical surface. When applied to GU-427, the screen displayed something that caused the entire team to lean slightly forward, as if we wanted to draw closer to the truth beginning to take shape. During moments of maximum solar interaction, the object's light adopted an internal pattern resembling a geometric weave, a barely visible lattice formed by coherence lines that corresponded to no documented natural optical phenomenon. These were not isolated peaks or noise, but an architecture that emerged, vibrated, and vanished in rhythm with a non-gravitational acceleration. I recorded this moment with a blend of precision and perplexity. The evidence had accumulated to a point where conventional explanations seemed inadequate. As I continued noting, the object's halo began to fade slowly. The intensity of the solar wind diminished, and with it, the complexity of the phenomenon. The pulses extinguished. The coherence dispersed. The light returned to its usual unstable glow. For a moment, I had the impression that the object had revealed all it could in this phase, as if it had opened a fleeting window, for a few moments only, to show its true nature. When the session ended, I remained motionless at my station, observing the final record. I realized we were not dealing with a comet, an asteroid, or a wandering fragment. We were facing something else, a category of bodies challenging our classifications, cosmic entities that seemed governed by unknown internal dynamics, capable of aligning, responding to the sun, and moving with motions that transcended gravitational determinism. As I closed the report, I knew this alignment would not be remembered as a chance celestial event, but as the first time contemporary science confronted a deeper, older, and more complex cosmic architecture than we had ever imagined.